Hey guys, Mr. Wilson here. Today we're going to talk about compound inequalities. At the end of this video, you should be able to solve and graph and compound inequalities. Okay, a compound word is two words put together. A compound inequality then is two inequalities put together. Okay, there are two types of compound inequalities that we'll look into this chapter. We have and inequalities, we'll say that, and or inequalities. Okay, so we'll look at and inequalities today and or inequalities in the next lesson. Okay, so here's and inequalities. Inequality number one, it says numbers greater than 2. If we're going to write an inequality for that, we'd say, okay, numbers greater than 2, x is greater than 2. Okay, numbers less than 9. X is less than 9. Okay. Another way of writing these two inequalities is kind of put them together. We want numbers that are greater than 2 and at the same time, oops, I wrote 9, greater than 2 and at the same time less than 9. A solution to this is a number that makes both inequalities true. Since there are an infinite number of solutions, we again need to graph to show all of the solutions. Okay, and before I get into this too far, remember that even though we're going to be between 2 and 9, there are an infinite amount of numbers. It's not just 3, 4, 5, 6, it's 3.1, 3.11, 3.1111. Okay, all those numbers work. So there's still an infinite amount of solutions. So as we graph these, really we're just going to look at these things separately. We have x is greater than 2, open circle at 2, going to the right. X is less than 9, open circle at 9, going to the left. Okay. And inequalities only work where both things are true. So just that space in the middle there are our solutions. Okay, looking at the next problem, it says Monday's high temperature was 74 and low temperature was 51. Show all temperatures from Monday. So here's our inequality. The high was 74, the low was 51. Our temperature was somewhere between there, so being greater than or equal to 54 and less than or equal to 74. Sorry, greater than or equal to 51 and less than or equal to 74. Okay, and now to graph that, again, we have 51 here, 74 here on our high end. These are or equal to, because if they were the high for that day, that means it actually did reach those, so they're part of our solution. And then we follow it and where they meet. So everywhere that they both can be true works. Alright, solving and inequalities. To solve and inequalities, we want to isolate the variable. Just like all other times that we're solving, to solve we get it by itself. However, the variable is found in the middle of two inequality symbols. These two inequality symbols create three sides to the inequality. Therefore, whatever you do to the middle of the inequality, you have to do the same thing to all three sides. Okay. So here we go. We have our first compound inequality here at the bottom. We have negative x minus 5 is greater than negative 4 and less than or equal to 3. And so as we solve it, what I like to do is I just think about the middle. I don't even worry about the outside. Think about the middle and say, okay, what do I have to do to get x by itself? Well, I have to add 5. And now I have to do that same thing to the other sides. So I'll know that I'm writing this 3 times for this inequality. So negative 4 plus 5, 1. Sign doesn't have to change. Sign doesn't have to change. Okay, 3 plus 5, 8. X is by itself, so I'm good. So x is greater than 1 and less than or equal to 8. So 1 here, 8 here, closed at 8, open at 1, greater than 1, less than or equal to 8. Okay, we'll do more on the back. Alright, so we'll finish some more problems on the back here. Alright, so again, when we're doing compound inequalities, or these and compound inequalities, we want to make sure that we focus really on getting the variable by itself in the middle. Okay, so whatever we do there, we're going to do to the other two sides. Trying to get x by itself, 3 is with it, it's multiplying, so I'll divide by 3 and I'll do that to each side. So now I'm left with negative 4 less than or equal to x less than or equal to negative 1. Okay, so I can write my compound inequality as x is greater than or equal to negative 4 and less than or equal to negative 1. Now if I make my graph, have my two numbers that are important here. They're both closed circles. Okay, so I'll go to the right here and to the left here. Alright. Number 2, again trying to get this x by itself, so I'm focusing on the middle. First thing that I want to deal with is that fraction, and I can get rid of it by multiplying both sides by 4, or every side by 4. Okay, and so that will give me negative 52 on the left is less than or equal to 3x minus 1, which is less than 20. Okay, I'll add 1 to each side now, just solving this. And so I have negative 51 less than or equal to 3x less than 21. And then I'll divide every side by 3. That should leave me with my final answer, which I'll just write on the solve line. And so that'll give me negative 17 less than or equal to x less than 7. So x is greater than or equal to negative 17 and less than 7. Okay. As I graph, I'll make sure I pay attention to the circles because my signs, they're different. So this is a closed circle. This will be an open circle. Connect them here. Alright, and there we have it. Alright. I'm going to leave number 3 for you guys to do. Bring in complete for me. Let's look at number 4. So number 4, again, it's the same process. We are going to get x by itself and focus on that middle before anything else. And whatever we do to the middle, we'll just do to the other side. So I have 10 here, 2/3 x, and 18 here. And then I'm going to get rid of this. Remember, we get rid of this fraction by multiplying by its reciprocal. Okay, because that's basically division. Okay. And so over here we get to cancel that out. So in our middle we're left with x. On this side I'll have 18 times 3, which is 54 over 2. Here I have 30 over 2, which I'll simplify my final answer. So 30 over 2, which is 15. 54 over 2, which is 27. And there we have it. And so I'll have 15 my low end, 27 my high end, and then x, there'll be open circles, and connecting them. Okay. Alright, last problem here that we'll do together. And we have a negative 7 less than 3 minus 2x is less than or equal to 11. So again, we're just getting x by itself. I'm going to subtract 3 from each side. And so that'll give me negative 10, negative 2x, 8. Alright, now I need to get x by itself, and I'm going to divide it by negative 2. Now here's the trick of this. We're dividing by a negative number. Remember that when we multiply or divide by a negative number, we have to flip our sign. And so, we can get our numbers right. We want to, I'll just put those out. Negative 4. Okay, and then we have to remember to flip the sign. So that just means that we'll be facing the other way. Here and here. Okay, that's because we multiply by a negative number. Alright. The other way you could do that, if you feel like this is confusing for you, okay, the other way that you could do it is you could cover this up and write the two inequalities separately. Okay, so I have 3 minus 2x is less than or equal to 11. And I could do the same thing here, cover this up and do negative 7, 3 minus 2x. Okay, however you do it, you'll be solving both this problem. So you could say this way as a compound inequality, but you could also, if you solve these individually, you get the same answer. And you could say x is less than 5 and x is greater than or equal to negative 4. Okay, so 2 ways that we can write those answers. I know we've been sticking with this kind of blended way, I guess I'll say that better, or combined way. But we can also write it with the and together, or there. Either way, the graph will look the same. Negative 4 will go here on the number line. 5 will go here on the number line. So again, we're paying attention to where those things go, so it makes sense. Even though 5 is on the left side, 5 would be furthest to the right on our number line. So closed circle for negative 4. And open circle at 5. Okay, and so we have x is less than 5, means it has to go this way. X is greater than or equal to negative 4, means it has to go this way. Alright, so there we have it. Some compound inequalities, really just solving 2 inequalities at the same time, and then making sure that you're careful to remember all of your inequality rules, especially the multiplication and dividing by negative numbers, but also the signs and the open circles and closed circles, and the things that go with graphing your solutions. Alright, see ya.